Okay, I'm
Yeah.
Taabu Simiyu from the University of Nairobi, Kenya. I'm presenting part of my work in my PhD, which I just completed. This work was sponsored by the GATS Magnet Fund, International Science Program, National Research Fund of Kenya, and we collaborated with BITRI, that is Botswana Institute Research, and University of York, UK. So in today's work paper, I'm going to present strength-porosity relationship in diatomaceous-based membranes and the role of aspect ratio in filtration. So before I just go on, diatomaceous earth is simply a clay with small holes, and aspect ratio is actually we get it by just dividing the axis of the pores in the membrane. And when I talk about filtration, I'm talking about a water membrane, I'm talking about a water filter, and I made them in this slide. So I don't know if my presentation is shared already. Okay, I try to share it myself then.
Can you try to share from your side?
Okay.
All right, there it is.
So I put in presentation mode.
Yes.
Just a minute. We can see it?
Yes, we can see it, but try to put it on the slideshow.
It's coming?
Next to, yes, okay. That's better now.
It's slow. Okay, those are common scenarios we see in Africa and most parts of developing countries. So the World Health Organization predicts that at least one person dies after 23 seconds due to waterborne diseases. The 2.3 million people that die annually come from developing countries, 80% of whom are mostly children and women. Because of these challenges, a lot of research has been focused on water purification, and this has yielded effective water purification such as reverse osmosis and ultrafiltration. Unfortunately, these technologies are costly to most of the developing residents of the developing world. Ceramic water filters, which will have come in handy to solve this problem, are brittle. It is because of this that we are doing a research on improving the mechanical properties of ceramic water filters by using a diatomaceous earth and organic binder made from Cochrares solitaris. And Cochrares solitaris in South Africa is locally known as Morogo. So we mixed this. This is part of the work we did. So I'm not going to really dwell in how we did this much because we have reported a lot on the procedures of how we did. So we mixed diatomaceous earth and the extracted organic binder to make these like membranes, which when they were not dry, they were looking like that. And we also improved the discs by firing them at different firing temperatures. And then we also carbon activated them using molasses. So today's work, we are basically characterizing, using the identified models on how the strength of this and porosity of these materials play in filtrations. So we were able to find out that, oh, my computer is hanging. So we were able to compare relative strength and volume fraction using the strength stress concentration effect model and minimum area model. And we were able to find out that for ceramic filters or diatomaceous earth membranes made from purely diatomaceous earth, which is diatomaceous A here, purely fitted the minimum area model, and then the membranes that were none, that were not made from the pure ceramics, that is the membranes that we added a charcoal, introduced a porous material to increase the porosity, fitted more in the stress concentration effect model. We were able to also notice that when we looked at the fittings of these models, we found that most of the models fitted well by giving us a very high squared value, and all of them gave us a negative correlation. However, when we looked at, that is for minimum contact area model, but when we looked at stress concentration model, we noticed that this model gave us a low fitting with only diatomaceous earth waste materials, giving us a better fit. Now, diatomaceous earth waste is actually not applicable in any purification systems because it's just wasted. Now, Kenya being a Rift Valley country hosting the Rift Valley is able to have a lot of fossils of diatoms, and they manufacture it. And so diatomaceous earth waste has been serving as a menace to the manufacturers, and they actually didn't know what to do them, but we did. But in our research, we were able to find out that this material is equally porous as the diatomaceous, the pure diatomaceous earth A that is purely used for filtration in industries. Diatomaceous B, which is actually taken as a very old fossils of millions of years, we were also able to notice that this material can also still be used for filtration, unlike the perception that is in the industry that this material can only be used for making paints or making thickening of paints. So we were able to see that if we concentrate on making the minimum contact area, fabricating our material, concentrating on the requirements of minimum concentration area model, we will be able to get a material that from both diatomaceous A, diatomaceous B, and diatomaceous earth waste to be a very good material for filtration. And to prove that, we were able to look at, actually, we were able also to look at the scanning electron microscope of the membrane, and we can see quite a porous material, as we can see. And even when we looked at a material that had, sorry for that, that had some charcoal 5% and a charcoal 10%. Charcoal here was used particularly to introduce more pores in the material, and at the same time we were also analyzing its mechanical strength and its porosity. So we were able to see that when we add charcoal 10%, we actually compromised the strength of the material, but 5%, it was able to give us more porosity. But unfortunately, as other papers have reported, this gave us a very minimal efficiency in terms of decontaminating the water. Now, when we look for aspect,
you have 1 minute left there, Mary.
Thank you. When we looked at the aspect ratio, we found out that the aspect ratio showed that most of our pores were cephaloid, or that were giving us almost 1 as a ratio. And that shows that the pores are continuous. So in conclusion, we're able to see that porosity and mechanical strength relationship of pure diatomaceous earth membranes fitted more the minimum contact area model, and stress concentration was only effective to porosity higher than 0.3. So we also notice that aspect ratio gives high efficiency in terms of removing decontaminating the water, but at the same time, it compromises the quantity of water filtered. Thank you.
Thank you very much, Mary.